Continuing on in section 8.3 here, example 4 is applying multiplication of binomials. A cylinder has the dimensions shown on page 500. Here it has our radius as x plus 1 and our height as x plus 4. We want to know what is the polynomial in standard form that best describes the total surface area of the cylinder. So remember, a cylinder, if we were to draw our net here, on the top we'd have a circle, on the bottom we have a circle. And the middle part of our cylinder here, we can draw that as a rectangle. Think about it like if we took a piece of paper and rolled it into a cylinder shape. If we unfolded that, it would still just be a rectangle. So to find our surface area, I have to find the area of my two circles and add to it the area of my rectangle. Area of a circle is pi times radius squared. The area of my rectangle here, this is going to be the height of my cylinder. To find my length, remember length times width here, it's going to be the circumference of the circle. Okay, if I wrapped this all the way around my circle, that would be the same distance. So it's going to be the circumference of our circle, and we find circumference by taking 2 times pi times radius, or pi times diameter. But here, since we have a radius, we're going to use 2 pi r. So my length, again, is 2 pi r. And my width is my height. So surface area of a cylinder is 2 pi r squared plus 2 pi r h. If you were to type into Google, what's the formula for surface area of a cylinder, or how do you find it, this is the formula that they would give you. And if you're like, that's a lot to have to remember, then you don't have to remember. Think about what it means. Surface area means we're going to find the area of all the surfaces. Here we have a top and a bottom and the side, the middle part. The top and the bottom and the middle part. So we take 2 times the area of our circles, and we find the area of our rectangle, which is our circumference, times our height. Now, let's plug in what we know. In my formula, I'm going to have a 2 times pi times my radius squared, and my radius I'm actually going to fill in, plus 2 times pi, again times my radius, times my height. And those values I'm going to fill in, those change. Here, my radius, x plus 1, my height, x plus 4. If we look here, I have a common factor, 2 of them actually. I have a 2 in both terms and a pi in both terms. So I can factor out what's common and multiply by what's left. So left, I have x plus 1 squared plus x plus 1 times x plus 4. So again, I just took out my greatest common factor. It's like our columns that were the same. Okay, that goes in front, and I multiply by everything that's left. Here, anytime we have something squared, it means we take our base times itself, and then we can FOIL. So x times x, firsts, outsides, insides, lasts. Combine our like terms. 1x plus 1x gives me 2x. I can do the same thing here. Here I have 2 different factors, so I can easily see that I need to FOIL them, instead of here when we had to remember that we take our entire base times itself. So firsts, outsides, insides, lasts. Combine our like terms. 4x plus 1x is 5x plus 4. Keep in mind this entire thing is still being multiplied by 2 pi. Again, we're going to go ahead and combine our like terms. X squared plus x squared, I put my quadratics together as 2x squared. X and x, I put my linear factors together as 7x. And my constants, 1 plus 4, gives me 5. And again, still multiplied by 2 pi. And I'm going to take that 2 pi and I'm going to distribute it in. In order for it to be in standard form, we can't have any more parentheses, and it has to be our biggest variable first. So our biggest degree first. 2 times 2 is 4. We still have a pi and an x squared. 2 times 7 is 14. We still have a pi and an x. And 2 times 5 is 10. We still have a pi. And this is our surface area in units squared. So again, here we're going to find the total surface area of a cylinder with a radius of x plus 2 and a height of x plus 4, and then write it in standard form. So surface area is 2 of our circles, so 2 pi r squared, plus our rectangle, our circumference, 2 pi r, times our height. So here's our formula. We're going to keep our 2 pi, we're going to fill in our radius and square it. We're going to keep our 2 pi, we're going to fill in our radius and fill in our height. So notice here that we have a 2 pi here and here. I can factor those out for now and just worry about what's left. So here my radius is x plus 2 and my height x plus 4. So once I took out the 2 pi's, what I have left is x plus 2 squared plus x plus 2 times x plus 4. I'm actually going to do my multiplication here because to get it in standard form, we can't have any parentheses left, and we have to have it in descending order based off degree. So here, when I'm squaring x plus 2, that means I take my entire base, x plus 2, times itself. Firsts, outsides, insides, lasts. Here, firsts, outsides, insides, lasts. Keep in mind, all of this is still inside our parentheses. We're adding them together. We can combine our like terms. My quadratic components go together, 2x squareds. Keep your variable the exact same. It's still quadratic, it's just combining them. Linear, I have 2 plus 2 is 4, plus 4 is 8, plus 2 is 10. And constants, 4 plus 8 is 12. And again, that's still being multiplied by this 2 pi. So I'm going to distribute into everything. 4 pi x squared plus 2 times 10 is 20 pi x, and 2 times 12 is 24 pi units squared. So again, it's in standard form because we have no more parentheses and our variables are in descending order from highest degree to lowest. Squared, linear, constant. In example 5, we're going to be multiplying a trinomial and a binomial. So here we can't use foiling. If we check foiling, firsts, outsides, insides, lasts, this x term gets left alone. Okay, we have to use everything. So we can't just FOIL here because we still need to account for that x. So the book shows it by multiplying columns, just like if we were going to take 315 times 27. Okay, we'd multiply, then we'd move over here and multiply. We can do it that way, but I'm going to show you guys with a table because I think that way is a little bit easier to keep track of things, especially when we start getting more and more terms. So here, just like we did in the first half of the section, 3x squared, x, negative 5. Sign goes with the number. We list out all of our terms, each monomial in our polynomial. 2x, and again, sign goes with negative 7. Here we're going to multiply just like we did before in our table. So we take one piece from our column times the row that makes that square. So here I have 3 times 2 is 6, x cubed. Add your exponents there. X times 2x, 2x squared. Negative 5 times 2x, negative 10x. Here, negative 21x squared, negative 7x, positive 35. So if we look here, there should be a pattern. We used each of these twice because there's 2 terms. We used each of these 3 times because the opposite one has 3 terms. If we check our variables, there should be patterns here. It doesn't always have to be going down by 1, but there should be comparable patterns. So here I have 3, 2, 1 for my degrees. Here I have 2, 1, 0 for my degrees. Goes down by 1. 3 to 2, 2 to 1, 1 to 0. Patterns. It's decreasing by the same amount each time. So just something to check there to make sure that your factors have the right variable parts. Another thing to think about here, guys, is however many terms are in our first one times however many terms are in our second polynomial, that's going to be how many terms we have before we combine our like terms. So here, because I took 3 by 2, I'm going to have 6. If I took like a polynomial with 4 terms times a polynomial with 4 terms, I'd have 16 terms before I combine my like ones. If I took a trinomial times a trinomial, 3 times 3 would be 9 before I combine my like terms. So something else just to make sure that you're not missing any. Here I'm going to combine these like terms and these and put it in standard form. So 6x cubed, negative 21 plus 2, negative 19x squared, negative 7 minus 10, negative 17x, and a plus 35. Same idea here. We take each term in our polynomial and make it a column. In our second polynomial, we take each term and make it a row. Again, signs go with the numbers. Drawing our table here. Remember, we're multiplying. So 2x squared times x is going to give me 2x cubed. Add your exponents. Here, negative 3x squared and just an x. Negative 6x squared, positive 9x minus 3. We can combine things with the same variable parts, x squareds and x's. 2x cubed minus 9x squared. Remember, here's a 1 if there isn't a coefficient already. 10x minus 3. It's in standard form because there's no variables left, there's no parentheses left, and our variables go in descending order based off degree. 3, 2, 1, none. And that is our simpler form. Real quick recap here for section 8.3. There are several ways to find the product of two binomials. We can use models, algebra, and tables. The properties of real numbers can be used to multiply two binomials. And that's all I have for section 8.3.